Okay, we're now going to talk about inverse functions, but before we actually do problems, let's first understand the notation and the idea behind what an inverse function is. This is the notation for an inverse function. This is read as f inverse of x. This does not mean 1 over f, right? That's not like raised to the negative 1 power, right? This is just the notation that's used for f inverse. So again, that's read as f inverse. What is an inverse function? Well, first of all, a function has an inverse. In order to have an inverse, it's got to be 1-to-1. It's got to pass the horizontal line test. This does. So it has an inverse. Now, what is the concept of an inverse? When you plug in an x value into f, what comes out is our y value, yeah? But remember, our y value is our f of x, because y equals f of x. All right. The idea of an inverse is, if you plug this y value into the inverse, it just takes you right back to where you started, your x value, yeah? So in other words, if I plug my y value, which is f of x, if I plug that into my inverse, if I plug f of x in for x, if I plug that into my inverse, it takes me back to my x value. This is why f inverse of f of x equals x. Similarly, if I plug the inverse function into my function, it's just going to give me x again. So that's the idea behind the concept behind an inverse function. Now let me explain why does it, well, you know what, I'm not going to explain that. This is the idea of the concept of an inverse function. So now in the next video, let's do some examples of actually finding an inverse function given a function.